So this is our second installment of the inverses of functions videos. And in the past video, we talked about the inverse of a function is just where you switch the domain and range. And what we did in that video is we looked at what does it look like on the graph. We would create some x and y coordinates, and then we'd switch those around so that the x became the y and the y became the x. Looked at the inverse and so on. If you didn't watch the video. So now what we're doing is instead of graphing it and making a table, we're just going to switch the domain and range in the equation. So let's run through a few examples. We'll start out with kind of a basic one, work our way into a little bit more challenging one, and just kind of walk through some sample problems of how to switch the domain and range around. So the example down here in green says, what is the inverse of y equals 1/3 x plus 6? And so, just like I said, we switch the domain and range around. And typically what we use for domain is x, and for the range, we use y. So now we're going to flip those around. So instead of y equals, it's x equals, not y, excuse me, got ahead of myself, 1/3 y plus 6. So we just switch the x's and y's around. And that's it, except we have to solve for y. So we want to always switch them around and then solve for y. And that's basically it. So if you know how to do that, try it, and then see if you get the same answer as me. So my first step would be, I want to get rid of this plus 6. So I'm going to do the inverse of addition, which is subtraction. So I'm going to subtract 6 from both sides. I get x minus 6 equals 1/3 times y. And then to cancel out 1/3, I'm going to multiply by 3 on both sides. The 1/3 and the times by 3 will cancel out, and we get y equals 3x minus 6, or if you distribute that 3 in, the inverse would be 3x minus 18. So if you got that when you tried this on your own, great job. You know how to find the inverse of a function. Of course, we start out with a pretty basic one, but let's do a couple more examples. They're not going to get super complicated, but complicated enough where you have to really know what you're doing. So here's example 2. If you're taking notes, I'd highly encourage you to pause, write this down, and then try it on your own. See if you can do this without my help. If you're not sure, watch how I start, pause it, and then see if you can finish it out. So this one is g of x equals instead of y equals. And so what I tend to typically do, and I don't know if this is mathematically okay or not, but what we all tend to do is we replace the g of x or f of x or h of x with y. So we rewrite it as y equals 1/x minus 3. So this is the original function in terms of y and x. The g of x is the output, y is the output. Then we're going to switch them around. And so for the inverse, which we call g inverse of x. It looks like it's g to the -1, but it's really g inverse. We're going to do x equals 1/y minus 3. All right, so this next step, there's a couple different ways you can approach it. But what I always do is when I want to get rid of dividing, and y is in the bottom, so I need to multiply to get it out of the bottom. So I'm going to multiply both sides of the equation by y minus 3. And the reason I'm doing that is because I want to solve for y, and since y is in the denominator, I can't solve if y is in the denominator, so I need to get it out of the denominator. So then what happens is on the right side, we're just left with 1. And on the left side, we're left with y minus 3 times x. It's super tempting to want to distribute that x. But I want to get y by itself. And so the quick way to do that is my next step is I'm going to divide by x. That way I'm getting y more isolated rather than when I distribute I end up with kind of a mess. You could do it, it's just going to be a little bit more messy. So we end up with y minus 3 equals 1/x. And then if I want to get y by itself, I undo subtracting 3, so I'm going to add 3. And I get y equals 1/x plus 3. And that plus 3 is not involved with that fraction. It's outside the fraction. So that's going to be our inverse. And the way we write this, instead of y equals, because there was no original y in the in the function, we're going to write it as g inverse of x equals 1 over x plus 3. So your final answer would look like the g inverse one, whereas g inverse equals 1 over x plus 3. Okay, let's do a third example, and then we'll kind of summarize everything. If you want to try this one on your own, I think that'd be a wise move. This one's got a few more complicated steps to it. Once again, pause, write it down, try it on your own, see if you get the same answer as me. So, first step, just like the last one, we're going to replace h of x with y. So negative in parentheses x plus 4 squared plus 2. Then we're going to switch. So now we're finding the inverse. Inverse. So this, the thing I just wrote down was actually the original equation. Now I'm going to find the inverse by switching the x's and y's. So x equals negative y plus 4 squared plus 2. All right, first step, I'm going to subtract 2. Get rid of that adding on the outside. I get x minus 2 equals negative, in parentheses, y plus 4 squared. And then I'm going to divide by negative 1 to cancel out this negative. And I'll take this over here. I get negative x plus 2 equals, in parentheses, y plus 4 squared. Now this is the point where I'm guessing if you paused, some of us may have made a mistake here. And the common mistake that people make is they're really tempted to try to distribute that 2 in there. And that is not okay. You cannot do that. When there's an adding or subtracting inside the parentheses, you have to multiply it out. If it's just y times 4, you can treat it like a distribution thing, but it doesn't work like that. So how do I cancel out squaring? Well, canceling out squaring is square root. And so when we do that, on the right side, all we're left with is y plus 4. I'm sorry, on the right side, all we're left with is y plus 4. On the left side, we have the square root of negative x plus 2. But I'm guessing if you got to this point without making any mistakes, you may have forgotten that when you square root a square, you end up with a plus or minus situation. So it's really plus or minus the square root of negative x plus 2. Then I subtract 4 from both sides. And I'm left with, I'm just going to write the y on the left side, not that it really matters. Y equals negative 4 plus or minus the square root of negative x plus 2. And that is almost our answer, except we're going to write it in the correct form. So since they used h of x to start out with, we're going to write h inverse of x equals negative 4 plus or minus the square root of negative x plus 2. And that would be our final answer. This is the inverse of the original function, and that is I can't say it's a function because this one's technically not a function. It's going to be a sideways parabola, which would fail the vertical line test. So what? A couple things that we need to summarize here. One, there we go. If you want to prove that 2 inverses are functions, or excuse me, proving inverses of functions, so let's say you've got 2 functions or equations, and you need to prove that they are indeed inverses of one another, then this statement holds true. 2 functions, f of x and g of x, are inverses of one another if and only if f of g of x equals x and g of f of x also equals x. So this is a kind of a technical math definition. This if and only if stuff right here, what this means is it's basically an arrow pointing both ways. So if you show that f of g of x equals x and g of f of x equals x, then you have proven that they're inverses. If you're told that they're inverses, then the stuff in that pink box has to be true. So the arrow points both ways, where if you know one thing, then the other thing has to be true, and vice versa. So let's put this in motion and see what this is saying. So we're going to do g of g inverse of x, and then we're going to do g inverse of g of x. This is like the Fogg and Goff situation from earlier. So what that means is I'm going to be plugging in the inverse function into g. So I'm going to take this whole thing and I'm going to plug it in where I see an x in the g function. Let me show you what I mean. We're going to write down the g function, 1 over, then instead of x, I'm just going to do a big parentheses. And I'm going to put the inverse in. So 1 over x plus 3. All right, so let's simplify this down. We have, I know there's some parentheses there. However, we can ignore those because it's all adding and subtracting. So this plus 3 minus 3 cancels out. We're left with 1 over x. And when we divide fractions, we can multiply by the reciprocal. So this ends up being 1 times x over 1, which is x. And that's what we need to get to prove that these are inverses of each other. And we also need to do it the other way around. So now, this time, what we're going to do, I'm going to erase my notes here. There we go. I'm going to do it in reverse. So I'm going to take, and I'm going to plug g of x into the inverse function. So let's see what that looks like. Let's write down 1 over x plus 3, and instead of x, I'm putting that g of x function in. So 1 over x minus 3. Well, this stuff on the left here is a fraction divided by a fraction. So I can multiply by the reciprocal. So it's 1 times x minus 3 over 1, and then plus 3. And then this ends up being x minus 3. If you multiply by 1 and divide by 1, those don't really do anything. So x minus 3 plus 3, the minus 3 plus 3 are inverses, so we end up with x. So by doing the composition and getting x when we do f of g of x and g of f of x, or in this case, g inverse and g, and if we get x, then they're inverses of one another. The other thing that we want to talk about, and I don't have something pre-typed here, but if we have, let's say, a parabola, and when we graph the inverse, like we talked about in the first video, it's going to be a reflection over the line y equals x, and so it's going to look something like that. So, when we want to figure out if this parabola is a function or not, we do the vertical line test. I'm going to do my best to draw a vertical line. That looks mediocre. And I'm going to grab this, and I'm just going to drag it across there. And this parabola passes the vertical line test. It never touches, well, except there because my line's not straight, right? But this passes the vertical line test because it never touches that vertical line more than once. So this is a function. However, the inverse would not be a function because it crosses that vertical line twice in many spots. So one thing you can do, if you don't want to actually have to graph the inverse, is you can take that original function and you can do the vertical line test to see if that's a function. And then what you can do is you can take a horizontal line, and that will tell you if the inverse is a function. So the horizontal line test, tells us if the inverse of a graph is a function. Tells us if the inverse is a function. And this is without having to graph the inverse. Without having to graph the inverse. So instead of doing a vertical line test, well, you still would do the vertical line test to see if it's a function, But then to determine if the inverse would be a function, you can run a horizontal line across the original graph, and that would tell you if its inverse would be a function or not. All right, this video got a little bit lengthy. I apologize for that, but that covers pretty much everything you know in terms of what you need to know for inverses of functions.